Hello and welcome to the EEPROM 9. And yes, we have a valve oscilloscope. I finally got hold of one. I've been after one of these because I wanted to do experiment with a valve restoration project because I've never done it before. I don't know much about valves. So, why not learn? And also, well, when all the old timers die out, the knowledge will be lost and we don't want that, so us younger ones must take up this knowledge and ensure it is preserved and practiced. So this is pretty much just a pet project for the fun of it, and I actually have a use for this thing when I get it fixed. It's absolutely disgusting and dirty inside, full of corrosion, but we've determined the high voltage circuit works. How did we do that? We went against all good practice with valve electronics, plugged it into 240 volts and switched it on. And we just got a little green spot on the centre of the CRT that didn't do anything when you twiddled the knobs, except change its brightness. But that's good, because the high voltage section of the circuit works and it uses solid state rectification. But the rest of the circuit doesn't use solid state rectification, and this is where one of the major problems lie. The little valve that does the rectification, this whippersnapper is dead. As you can see, it's kind of a grey getting close to white. It should be silver like these are. Yeah. Somehow the atmosphere has penetrated inside it and is destroying the vacuum. The filament still lights because I just powered it up with my power supply just to test it. CRT's good, and it's the same type of CRT that's in my Hameg HM307, which is currently at work. Mine's the A variant in my Hameg. This is the non-A version of the rounded. The difference is basically the A version has a flat face to the CRT. This is a rounded face to the CRT. So I could easily swap this into the Hameg, maybe have to modify the front, maybe I could get away with it because of the way it clamps, just have the tube further back. But yeah, so this isn't getting the power it needs. On top of that, these resistors, all the little lighter coloured ones, they all seem to be A-OK. That's 100k measuring 100k, measuring 100k. I haven't tested all of them further back in there. Coils I haven't tested if they're connected. The pots I haven't done anything with. These will most definitely need contact cleaner in, if not completely replacing. So I'll have to measure them, figure and work out what their original values were. Hopefully they're fairly standard. 20k, yeah, that's pretty standard. That one is, I don't know. That one is, trouble is this corrosion wiped off the markings. One thing you have to be careful with this old kit, sometimes it can be cadmium plating, so I'm not going to go for an abrasive method. I think I'm going to finally test out some electrolysis, but I'm probably not going to do the whole thing. Just the bits like that, things that I can get out easily, because I don't really want to take apart the whole chassis because I can't find a full manual for this thing online. Now, I've ordered a new valve. I ordered this pretty much the day I saw it was like this because if it worked, it was on its last leg, and it doesn't work. And I've got the weaker variant, the EZ80, simply because it was cheaper. These things are expensive. Seriously. I was surprised at how expensive they are. Sadly, it's not a job lot valves I got it in. The caps are pretty much probably going to have to be replaced. I don't have any way of measuring capacitance leakage, but I am drawing up some plans in my head now I understand how a capacitor leakage tester works onto building and designing my own. So I'm just running over some plans, and you need like a nice high voltage power supply. Well, I don't have any step-up transformers, and I don't fancy doing full-on mains. unisolated because I don't have any isolation transformers. So I'm thinking, why not use a CFL inverter and then just control the input voltage, because through that that's the way I did the high voltage for my Geiger counter I built. I could use the same method and put it for a resistor divider that's just tied to a knob, and then I can adjust the voltage. So yeah, these electrolytics, I ran a thing with them on the ESR. ESR's okay, but the value is way off. So these mofos need deleting and replacing. Some of the resistors are going to need replacing. Haven't tested this, to be honest. It's like, you want to do leakage testing. Yeah, the little diode back there's A-OK, so he will remain in place until he decides to die, because my experience with vintage diodes is they're not the most reliable things on earth. So that's just one thing to keep in mind. This CRT runs on about 1,000 volts, because it's the same spec as in the Haymeg, so it's actually a pretty safe CRT to work with. I find it doesn't actually seem to store a charge. Now, don't take this as a general rule, but what I've noticed with these ones, where it's all internal coating and no EHT plug, is they don't seem to store a charge because they don't have the external coating, the glass acting as the insulator between the two capacitor plates of the inside coating and the outside coating. So these ones don't seem to actually act as a capacitor. When you switch them off, they're safe. That's from what I've noticed. I haven't actually done any testing to back this up, and when I eventually get round to high voltage probes and building something like that, then I will do that, and I will be doing high voltage experiments at some point. I have a MOV transformer. Oh god, I didn't check if that microwave's still there. I rode past yesterday. If it is, I want to salvage out its transformer and badass cap. I'm not so bothered about salvaging out the rest of it. I just want those two things. So yeah. Valve oscilloscope restoration. I've got some preliminary debugging info going. I've been watching YouTube videos on Valve stuff, so I've got a rough idea of what I'm doing. What the hazards are. At least there's no hidden asbestos in this thing. That can be a problem with some devices, especially anything that has heating elements from this era. But although sometimes it's used in insulators and that, but this thing seems to be pretty free of the stuff, which is good. Because then I would have to dig out one of my gas masks or something and just like remove it, chuck it in the bin and forget about it. My solution, we'll bag out before you chuck it in the bin. Or take it down the dump to they actually have a bin for asbestos there, but yeah, nothing to worry about. Did you know there are vintage gas masks that the filters use asbestos in? I have some of those gas masks. Yeah, I won't be disposing of them. They're part of my little gas mask collection, which isn't very big. Not every collection has to have 1 million things. I seem to be collecting oscilloscopes now. It's like 1, 2, 3, 4, 5 in the cupboard and 6 at work. So yeah, I seem to be unintentionally collecting oscilloscopes. I don't know when this became a thing. It's just, I like the project. I like just messing around with things. It's just like, oh, that looks interesting. Bye. Something new to play with. Bored of playing with the other thing. Finish this. Need a new project. This. So yeah, thanks for watching. Hope you enjoyed. I'm going to go back to just doing what I was doing. Basically waiting on a new one of these, and I need to spec out what caps I want to replace. There aren't any wax ones in here. They're all like plastic things like this, but I have no way of testing them at the moment. I should probably get around to designing and building that tester. Then I'd know for certain, especially on the high voltage ones, although the high voltage circuit does work, which bodes well for those caps actually being at least workable for the short-term future. Thanks for watching. Hope you enjoyed.